Hello, good day, viewers. Sometimes solving trigonometric equations might seem to be very difficult, but we know that solving algebraic equations is very simple. This is why algebraic substitution is very much useful. We are given that if tangent of theta divided by 2 is equal to t, and tangent of theta is equal to 2t divided by 1 minus t squared, we want to find the rest of the six ratios. Already we have 1 here and 1 here. So we want to find 5 in terms of this tan theta divided by 2 and also 5 here. You can see in both cases we are using algebraic substitution. And in the end, I will show you the origin of this tangent theta divided by 2 and also tangent of theta. So let's get started. So let me start with the first one here. We are given that tangent of theta divided by 2 is equal to t. From here, I can find cotangent, right? Cotangent, which is the reciprocal of tangent. Cotangent of theta divided by 2 is just the reciprocal of t, which is 1 divided by t. So this is the first one. Then sine and cosine, we're going to use a right angle triangle. And this angle right here is theta divided by 2. So what is tangent? Tangent is opposite divided by the adjacent. This is the opposite and this is the adjacent sides. So given that tangent of theta is equal to t, which we can rationalize as t divided by 1, this implies that this is the opposite and this is the adjacent. So the opposite is t and the adjacent is 1. So what will be the hypotenuse? The hypotenuse will be the square root of t squared plus 1 squared, which is the same thing as 1. All right, so from here we can derive sine and cosine. So let me start with sine. Sine of theta divided by 2. Remember, it is opposite divided by hypotenuse. The opposite is t and the hypotenuse is square root of t squared plus 1. So we have t divided by square root of t squared plus 1. So this is sine theta divided by 2. What about its reciprocal, which is cosecant? Cosecant of theta divided by 2. Just flip upside down what you have to the right hand side. It will be the square root of t squared plus 1 divided by t. And this is another important one. Then for cosine, cosine of theta divided by 2, this is adjacent divided by hypotenuse. The adjacent is 1 and the hypotenuse is square root of t squared plus 1. So this is cosine theta divided by 2. So what about secant, which is the reciprocal? Secant of theta divided by 2 will be equal to, you flip upside down what you have to the right hand side, which is going to be square root of t squared plus 1. This is another important substitution. So we have just written all the 6. You see, we have 4 here and we have 2 here, making 6. So now let us take the other one, which is tan theta equal to 2t divided by 1 minus t squared. So this is that. Let me draw a right angle triangle here. We have angle theta here. And remember that tangent is equal to opposite over the adjacent. This is the opposite, 2t. The adjacent is 1 minus t squared. Then what will be the hypotenuse? It is going to be the square root of opposite squared, 2t squared, then plus the adjacent squared, 1 minus t squared, also squared. So let me expand the argument, which is the term under the square root. 2t squared is 4t squared plus this one you have first time squared 1 squared plus second time squared t squared squared is t to the power of 4, then minus 2 times 1 times t squared is 2t squared. This minus this is 2t squared. So we have 2t squared plus 1 plus t to the power of 4. If you further rearrange this, this becomes t to the power of 4 plus 2t squared plus 1, which can be factorized in terms of t squared. So this is t squared plus 1 all to the power of 2. Exactly. But if you plug in this into the square root will cancel power of 2. Therefore, the whole of this is equal to t squared plus 1. Let me start with sine. Sine of this angle theta is equal to opposite divided by hypotenuse. Opposite is 2t divided by hypotenuse, which is t squared plus 1. Its reciprocal, which is cosecant, is equal to t squared plus 1 divided by 2t. Important substitution. What about cosine? Cosine of theta is equal to adjacent divided by the hypotenuse. And what is the adjacent? The adjacent is 1 minus t squared, and the hypotenuse is t squared plus 1. So we have 1 minus t squared divided by t squared plus 1, and its reciprocal, which is secant theta, is equal to t squared plus 1 divided by 1 minus t squared. Another important substitution. Are we done? I think the only one we need to find is cotangent of theta. Let me just take this down. So if this is tangent, cotangent will be equal to 1 minus t squared divided by 2t. And this is the last one. You see, we have 6 of them here. So where do they come from? That is the question. All right, let me drive them for you. Remember, if you have tangent of double angle to theta, this is equal to 2 tangent of theta divided by 1 minus tangent squared of theta. What if I should divide this angle by 2? That will give me tangent of theta, which is equal to 2 multiplied by tangent of theta divided by 2. We are dividing the angles by 2. Divide by 1 minus tangent squared theta divided by 2. So from here, we can let tangent of theta divided by 2 be equal to t. So let me write it here. Let tangent of theta divided by 2 be equal to t. That is the main origin of the substitution. So we have that tangent of theta is equal to 2 multiplied by t divided by 1 minus t squared. Can you remember this? Tangent of theta? This is exactly what we have here. 2t divided by 1 minus t squared, isn't it? Right? So from here, we have seen that tangent of theta divided by 2 is equal to t, and tangent of theta is equal to 2t divided by 1 minus t squared, and that's what we have started with. Can you see that? So if tangent of theta divided by 2 is equal to t, tangent of theta will be equal to 2t divided by 1 minus t squared, and all other ratios follow. So now the question is, how can we apply this in solving trigonometric equations? So we have a problem here that I'm going to solve subsequently. You can try that on your own and stay tuned for the solution. Bye bye.